In previous videos, we looked at multiple different integration techniques. We've seen integration by parts, use substitution, trig substitution, partial fractions. There's multiple different techniques. The issue is knowing when to use which one, because you're not always told which method to use. That's what we're focusing on in this video. The first thing you want to look for is an obvious integral, like in part A. If it's not obvious, maybe try a substitution. If substitution isn't clear, maybe try to classify it. Look at the integrand and determine, is it trigonometric? Is it rational? Is there a product? Maybe we need to use integration by parts. It really comes down to practice. Knowing when to use which method comes with more practice. Notice that in these three examples, they all look very similar, but they may require different techniques. The first one, hopefully, is a familiar integral. This one is simply inverse tangent x. The second integral isn't quite as simple as the first one, but hopefully we can see that a substitution is going to help. If we let u be x squared, then du is 2x dx. Notice that 2 doesn't occur in the original integral, so we'll divide by 2. 1/2 du equals x dx. We can now rewrite that original integral. The x dx part we are replacing with 1/2 du. We can pull 1/2 out front since it's just a constant. And in the denominator, we have 1 plus x squared we are replacing with u. At this point, we can integrate. We have 1/2 ln of 1 plus u plus c. But notice we're in terms of u, and the original integral is in terms of x. We need to make sure we go back and replace u. So 1/2 ln, absolute value of 1 plus, we said u is x squared. And then don't forget the plus c. In this example, notice that the denominator is a difference of squares. Let's try factoring that. We'll get 1 minus x times 1 plus x. Since we have two linear factors in the denominator, maybe partial fractions is going to be the way to go. So let's start by rewriting this as a divided by 1 minus x plus b times 1 plus x. I'm going to temporarily ignore the integral for now and just focus on the partial fractions. We'll put the integral back into it later. Let's multiply by the LCD. That is 1 minus x times 1 plus x. We need to make sure we do that on both sides. And when we multiply on the left side, notice the LCD and the denominator cancel, leaving us with just the numerator, which is x. Then distributing the LCD with the first fraction, we'll have a. Notice that the 1 minus x will cancel, leaving us with 1 plus x. And then distributing the LCD with the second fraction, we have b times 1 plus x will cancel, which means we're left with 1 minus x. At this point, we have a couple different things that we could do. We could equate coefficients, but since these factors are both linear, it may be easiest to choose clever values for x. So if we want this to go away to 0, we can make x -1. So let's do that. Let's let x be -1. Then rewriting this equation, we would have -1 equals a times 0. Again, we're replacing x with negative 1. So this is going to go to 0, which means this term goes to 0. We have b times 1 minus negative 1 is 1 plus 1, or 2. Then b must be negative 1/2. We can do a similar thing. We can choose another clever value for x. Notice if this x is 1, this factor goes to 0, which means the term goes away. Let's let x be 1. And now rewrite the equation. We have 1 equals a times 1 plus 1 is 2. And then again, if we make this 1, this term goes to 0. So a, if we divide by 2 on both sides, is 1/2. Now we can rewrite the original integral. I'm going to call that original integral I. I is equal to the integral of a, which we found to be 1/2, divided by 1 minus x dx, plus the integral of b, which we found to be negative 1/2, divided by 1 plus x dx. Integrating these, we'll get 1/2 natural log of 1 minus x minus 1/2 natural log of 1 plus x plus c.